In this section, we are going to review some more motion problems that we had done previously. And this is all going to be with your graphing calculator. So I have that out. Okay, so first of all, it's asking when is the object at rest? It gives me the velocity function. So remember, anytime it's talking about motion, you always want to be looking at the velocity function. So even though you're going to be using your calculator, make sure you always tell me what you're doing. So we want to find the places on the graph where the velocity is 0. So you would plug in the velocity function in y1. You can have y2 be the 0 graph, and then just look for the points of intersection. Notice I only care about time from 0 to 2, so you can set your window up accordingly. And it only happens at 2 places. These are my 2 values of t. Okay. What is the total distance traveled by the particle during the first 2 seconds? So remember, think about the car. If it goes forward 10 miles and then goes backwards 10 miles, we want to count both of them as positive. So you need to actually look at the absolute value of the velocity function. So what you're going to be integrating, so if we want distance, I need to integrate the velocity, but you need to look at the absolute value of the velocity function. If you don't know where the absolute value key is on the graphing calculator, if you go to math and move over to num, the first thing there should be your absolute value. So make sure you're integrating the absolute value, and that will give you your total distance traveled. So like in the car example, it will count that negative 10 meters as 10. Okay. Next, I want the position at t equals 2. So let's say x is your position, right? So I am trying to figure out this value right here. And it tells me that the position was already at 3 at time 0. So at 0, the position was 3. So this is what we're given. This is what we're trying to get to. I only have the velocity function. So to get from velocity to position, we need to take the antiderivative. This is what I always do. I always set up kind of like the general formula. So I'm going to take the antiderivative velocity. I'm given 2. I'm looking for the position at 2. I'm given the position at 0. So those are my 2 times that I want to use. And the idea is when you take the antiderivative velocity, that will give you position. And then what do? We plug in the upper bound, and then same thing, and we subtract the lower bound. So this is your general formula, and we're looking for x of 2. So notice if you solve this for x of 2, it's really this. And the idea is this. This will give you the extra distance the particle has traveled, but we know it was already at 3 meters to start. So this piece, you're going to go ahead and type into your calculator and then add the 3 afterwards. So we want 3.5509. Okay, so you want to make sure you either show me this or this, some variation of this formula so I can see what you are doing. Okay, next one. It says a particle travels along the x-axis. Again, we are given the velocity function. Average velocity. Again, anytime you see that word average, you're thinking that 1 over b minus a integral of f of x. Whatever it is asking you to take the average of, that's what you're going to integrate. So here, I'm going to go from 3 to 0, and I'm going to integrate the velocity function, and I could just use v of t since it was defined. Just use your calculator to do all of this, and you should get 0.120. Okay, the next one. Again, I'm given velocity. I want the acceleration at time equals 3. So this is just understanding, do you understand that derivative of velocity is your acceleration? So you're going to type this into y1, have the calculator come up with the derivative, and you just get this number. Lastly, a particle travels along, sorry, not the last one. Particle travels along the x-axis such that its velocity is given. I want average acceleration. Okay, so again, there's that word average. So I'm thinking 1 over 4 from 0 to 4. And this is what you're going to integrate. So I need that acceleration function. Okay, well, I don't have the acceleration function, but I do know how to take the antiderivative acceleration. You're only given velocity. It's the velocity at 4 minus the velocity at 0, right? The antiderivative is velocity. We plug in the upper bound, plug in the lower bound, and then you can go ahead and punch the numbers in your calculator. Okay. And lastly, again, I'm given a velocity function. Position of the particle at 1.5 is -4. So it is telling me that the position at time 1.5 is -4. What is the position at time 4? So always write what you're given. And I want this position. So I'm given velocity, so I know that if I take the antiderivative velocity, I will get to position. These are the two times that I want to use. And I know the antiderivative velocity is the position, and we're going to plug in the upper bound. Same thing here, subtract the lower bound. And we're looking for x of 4, so this is very similar to the problem on number 1. Really, the position at 4 is the starting position at 1.5, and you're going to add on that extra distance that this particle has traveled. So this is going to be -4, and then this, use your calculator for whatever that value is. And I'm going to get a value of -12.353.